And the first thing we're going to talk about is just the subsets of real numbers. Okay, so this is something that you should have been exposed to in a number of different times. Okay, the first thing is just the different classifications. And we're going to start with the smallest one that we have, and that is natural numbers. And natural numbers are just the set of counting numbers beginning with 1. So 1, 2, 3, 4, 5, 6, and so on. That would be your example of natural numbers. If you extend this out by one more number, you get the next subset, which is called whole numbers. Okay, whole numbers is all of these natural numbers with the addition of 0. Okay, so if I label it this way, is everybody able to understand what this represents? So whole numbers are 0 plus whatever is embedded within it, so 1, 2, 3, 4, and so on. Okay, so whole numbers begin at 0, and then it's all the counting numbers beyond that. If we take the mirror images of these on a number line, then we get the set of integers. So integers would be the set of positive and negatives. So again, the way I'm going to represent that is just here. Okay, so the dot, dot, dot just means this pattern continues. So -4, -5, -6. And then because integers is embedding whole numbers and natural numbers, it includes 0, it includes 1, 2, 3, and so on infinitely. And once you get to the set of rational numbers, which is kind of the next set, rational numbers are the set of numbers that can be expressed as the ratio of two integers. Okay, so rational numbers, they include all the natural whole and integers, but they also include fractions. Okay, so positive and negative. They include terminating decimals. So something like 0.51, -3.6671, or whatever. Any decimal that ends is considered a rational number. And then finally, it is any non-terminating but repeating decimal. Okay, so this would include something like 0.333, okay, where the 3's continue. That can be expressed as a fraction or a rational number. It includes, again, we can use a bar to represent the repetition of digits. So 5.31573157, again, the bar over the top indicates that that setup of that pattern of digits continues. And so that would be your set of rational numbers. Okay. Separate from this is going to be the set of irrational numbers. So any real number that is not rational is considered irrational. So irrational numbers cannot be expressed as a fraction or a ratio of two integers. It includes any radical that can't be simplified into an integer value. Now, when I get to, let's say, square root of 4, would square root of 4 be irrational? Square root of 4 has what value? 2, so where does that fit? Right here, all the way in here. It's natural, it's a whole number, it's an integer, it's a rational number. So it's all of those. Okay, but square root of 2, square root of 3, square root of 5. Okay, cube roots that don't simplify. Okay, it also, irrational numbers include symbols like pi and e that are just symbols that are given to specific irrational numbers. And so those would be the most common ones that you would see. Okay, the whole set, this entire set of numbers, rational and irrational combined, those are your real numbers. And so one of the things that you are going to be asked to do is you are going to be asked to classify. So you'll get a set of numbers and you'll be asked to identify which, if any, of these classifications the number falls into.